Hello, I'm James for Kit Guru. Welcome back. Those of you that have been following our Seasonic Aura custom build project, you'll have noticed that the system has been starting to take shape over the last couple of weeks. There's still a lot to do though, but I'm hoping to get this system all finished off, completed and up and running by the end of this video. So there's a lot to do, there's a lot to go through, and I'm going to be focusing on the power cables. We'll be building some custom cables and just basically tidying up the system, finishing off all the little bits and bobs and all just putting the final touches to the system. But like I said, there's still a lot to do. We still have the custom loop to build as well, so that'll be one of the last jobs. But before we get into that, I just quickly want to remind you guys that have not subscribed to the Kit Guru channel yet, make sure you do that today, and you can hit the like button and hit the bell button for notifications. And if you want to help support Kit Guru in other ways, you can always head over to our store, pick up some Kit Guru merch, and you can connect with us through social media such as Facebook, Twitter, Instagram, and our Discord channel. And as always, you can head over to the kitguru.net website where you can catch up on all our in-depth technical reviews and catch up on all the latest hardware news. So the eagle-eyed viewers among you will notice there are some subtle changes since the last time we saw this system. I've actually replaced this aluminium panel down the side of the motherboard. I've just swapped it out for one that has the Seasonic Aura logo laser cut rather than etched. I just think that stands out better with the aluminium and the black logo. And I've also just swapped this graphics card backplate. The original one had screw holes in it, and I've just had one that's continuous. I just think that looks a bit cleaner and a bit better, nicer looking without those screw holes there. So first on the job list today is making up some custom power cables. I'll be showing you exactly how you make your own custom power cables. We'll be using some PET sleeving and basically just making all the power cables from scratch. For the first part of this cable modding video footage, I actually filmed a couple of weeks back just in preparation of this today. And if you notice some of these boxes moving around on this backdrop, it's not because I'm a magician, it's just because we've filmed parts of this at different times. So let's crack on with that and have a look at how we make these custom cables. With custom cables, there's different routes you can go down. There's the extensions such as these from Silverstone, and these just plug in to your original cable. So this is the 24-pin ATX connector, and that just connects up to your original cables, extends them, and it looks a bit nicer than what you typically get with the power supply. But the only problem with that is you end up with a humongous piece of cable, and the majority of this part you've got to hide somewhere. So they're good for people that are not really into making their own parts, or don't have the time, or don't have the knowledge. They're ideal for that, and you know, they're not too expensive. So that is one option. The second option is something like this Pro PSU cable kit from Corsair, and what these do is these actually replace the cables that come with the power supply. So these are probably like the next step up from the extensions. They are a good option. The one limit with these is you are stuck with the length of the cable that they come in. So you've still got quite a lot of cable to hide when it comes to cable management. And then the third option is to make your own custom cable, so custom length and custom sleeving. So that's what we'll be doing, using some of this 16 gauge wire and these this PET sleeving from MD PCX. This was actually supplied by a company called Pexon PC. They helped us out and sorted us out with that. The first stage of making up your custom cables is to figure out the pinouts on the original cables, because we're not going to be using these at all. We're going to be making these of our own in a custom length and with this sleeving on. So we need to kind of reproduce these cables, but at the correct length we need. So we need to find out which pin on the 24 pin goes to the pins on the power supply end, and same with the PCIe cables, and same with the EPS power cables, SATA cables, and Molex as well. So you don't need many tools for this stage of the custom cabling. We just need a multimeter, digital multimeter, and the other thing that I found really handy is this template from PCMods.com, and this gives you images of the different connectors, so the 24 pin the PSU side of the 24 pin, the PCIe cables, and the CPU EPS cables, as well as Molex and SATA cables as well. So these just give you diagrams of the actual connectors, and you can print these off, and this will help you kind of map out how the pins on the 24 pin correspond to the power supply side. So what we need to do now is use the multimeter and set the multimeter to continuity, and that's continuity with a bleeping sound. So we look at the diagram, find pin 1. You can actually see pin 1 on the connector. So we'll just put one end of the probes into that, and then take the 24 pin. We just need to check which one that number 1 pin corresponds to on this 24 pin side, and as you can hear, we get a bleep there. So that's pin number 6 on the 24 pin. So we go on to the template, find pin number 6. Number 1 starts at this side, so 1, 2, 3, 4, 5, 6. That's pin number 6. So we need to mark down 1. So pin number 6 on the 24 pin side goes to pin number 1 on the power supply side. So that's the first one marked out. And then we continue this. So now we'll put the probe in pin number 2 of the 18 pin connector. And then same again on the 24 pin side. We just need to test that, and there we get another bleep. So that is pin number 23. So pin 23 will be here. Pin 23 is there, so that goes to number 2 on the 18 pin. So now we just need to do that for the rest of these pins on the 18 pin connector, and same on the 10 pin connector at the power supply, and then we'll find out exactly where all these 24 pin connections go in relation to these 18 and 10 pin connections. One thing that's worth noting about the 24 pin ATX connector is some of these cables are doubled up at the 24 pin side, so you just need to mark that down on the template sheet. I've just put some little red marks next to the pins that are doubled up, so the rest of it's pretty straightforward. Now we know how all these pins on either end of these cables relate to each other, so that should make it a bit more straightforward when we come into actually making the new custom cables. So something else that's worthwhile doing while you've got the power supply and the system in this state is working out the voltage at each one of these pins. So the PC power supply outputs 12 volts, 5 volts and 3.3 volts. So it's good practice to figure out what you're getting at each pin right now, because it's another good way to double check the custom cables are correct when you've made those up. You can check that the voltage at these pins are the same on the standard cables and on the new ones. So the way we do that is we take this test connector, this 24 pin test connector that is provided with the Seasonic power supplies, connect that up to the 24 pin connector. And what that does is it just jumps the switch wire to ground, so that when we switch it on at the back now, the power supply starts up. So now we need to set the multimeter at 20 volts, and then take the negative probe and just try and wedge that in something that'll be grounded. So I'm just wedging it in this bit of the power supply fan shroud. That should be grounded. And then now you can just take the positive end, or the positive probe, and then start with pin 1. So pin 1 showing 3.3 volts, so we can mark that down on a fresh one of these templates. So pin 1's 3.3 volts, pin 2 is 3.3 volts, pin 3, that's showing nothing, so pin 3 is ground, and then pin 4 is 5 volts, pin 5, that's a ground, pin 6 is 5 volts, and so on. So that's a good idea to do this bit before you go any further, and just again, it's just to make sure that you're getting everything right and the last thing you want when you've built your new cables is to plug them in and for something to go bang. So it's just double checking, it's just another way of double checking again. So that's how you figure out the pinouts for the new cables, but to actually make the cables you'll need a few basic tools, nothing expensive. This won't break the bank, but you will need these tools to complete the job. So as we've seen, you'll need a digital multimeter. You'll also need some form of wire cutters. Just use some diagonal cutters, and some kind of automatic wire strippers will come in handy. You'll also need a lighter, it's very important, and some staples, and I'll explain why you might need these later. You'll also need some soldering equipment, so you'll need a soldering iron and some solder. And one of the most important things you'll need will be one of these crimp tools. Now, you can buy various different versions of these crimp tools. Molex do their own version, which is quite expensive. You pay around about £200 for one of those. And you can also get one from MD PCX, which is a bit more cost effective. I think they're around about £50. But this one is just a cheap version off Amazon. It may not be up to the same quality as those more expensive versions, but once you have a bit of practice with this, this can do crimps just as well as any of the others. So that's the tools you'll need. There may be one or two other things that we come across, but you should be able to get by and make up the cables using those tools there. And obviously you'll need all the parts to make up the cables as well. So first you'll need some sleeving. This is PET sleeving. I prefer to use this rather than the paracord. I find this easier to work with, and it holds its shape better than paracord as well. So we picked this up from a company called Pexon PC, and this is MD PCX sleeving, which is, in my opinion, the best available. You also need some wire. I tend to stick with black wire and then just change the colour of the sleeving to match the system. This I buy from RS Components, and for the main power cables such as the ATX 24 pin, the PCIe and the EPS power cables, I use a 16 gauge wire. For the SATA cables, because the connector housings are a bit smaller, I use 18 gauge wire. You'll also need some heat shrink wrap. This is a 5mm diameter heat shrink wrap, and you'll need one that has a shrink ratio of 3:1 or 4:1. Obviously, you'll need some connector housings. Again, I buy these from RS Components. These are relatively cheap, and you've got your ATX 24 pin, PCI Express, EPS, and then all the different connectors that go to the power supply, as well as SATA and Molex as well. And you'll obviously also need the terminal pins as well for those connector housings. Again, RS Components sell these, and you kind of buy them on these magazines and then they just snap off. And then the other thing you'll need is some cable combs. I think I bought these from Pexon PC with the sleeving, and again, you can buy these in all different sizes for the different cables. So these long ones are for the 24 pin, and you can get them for PCI Express and for EPS and everything else. And they're again available in all different colours, and you can also get them in aluminium and different materials as well. So you'll need those, and you'll need to put those on halfway through one of the stages of building the cables. So let's get on to actually building the cables, and to save a bit of time, I've already made up a couple of them, and you can see they've got a blue and black theme to them, which will match in well with the system. These are the PCI Express cables. I also have some short SATA cables for the two SSDs down at the bottom, and that's another PCI Express cable. You'll see that one's a 6-pin cable, the other one's an 8-pin, because we have 6-pin and 8-pin connections. And then we also have the EPS cable and another SATA cable there. The first step of making your own custom cables is measuring out the length of the cables, and I'll be showing you the ATX 24 pin because that is the most tricky one to do. Certain systems you'll want to be very accurate with the length of the cables, but with this case we have a lot of space in the power supply shroud to hide excess cable, and there's also a plastic cover that covers up all the back of the power supply shroud as well, so it's really easy to hide cables away in this one. But there's a couple of different ways you can measure the cable. You could use a piece of string and kind of route it through roughly where it's going to go, kind of map out the length of the cable, or you can use some wire, and this might be the better way to do it because this kind of holds the shape a little better. So you just do the same thing. So you just start from the connector that you'll be using, and then just follow the route that you want the cable to take down to the power supply until you get the length of the cable. So for the ATX 24-pin cable in this system, we want the wire to be 920mm long. So I'll use this handy rule that is on my AlphaCool mod mat and just measure out 920mm, and then just cut the wire down to 920mm. And if you got the wire on this reel, it does end up being a bit curly, so you just straighten that out a little just to make things easier later on. So that's one length of cable. And obviously for the ATX 24-pin in our system there's 23 cables, so we're going to have to cut 23 pieces at 920mm. So there are the 23 pieces of 16 gauge wire for our 24-pin cable, cut to 920mm length. We also are going to need a load of these terminal pins. So like I said previously, these come on this kind of magazine reel, and so I need to snap off roughly 40 odd of these. So this is a little bit time consuming and boring, but it has to be done. So when we worked out the cable pin out for the 24-pin cable, we noticed that our Seasonic power supply uses some double connections. So a couple of the terminals on the 24-pin connector use double wires. So I've just cut some 100mm pieces of wire, of the 16 gauge wire, and I'll show you how we make those double cables now. So to make up these double terminal connections, you need to take one of the long pieces of wire and then bare the sheathing back on that. That should be enough. And then you need to do the same for these two smaller pieces of wire. We'll take roughly about 15mm of the sheathing off. Just twist the bare wire together on all three pieces. Then we need to tin each piece of wire with some solder. So just prime the soldering iron up, and then just tin each bit of wire. And then take the long piece of wire and one of the short ones, put them side by side, and then try and solder these two together, keeping them as close to each other as possible. And then take your other short piece of cable, solder that to both of the other ones. You may need to just add a bit more solder at this point. You can see all three cables nicely soldered together. And then to cover up that soldered joint, just use some of the heat shrink. Slide that over and cover the joint up. And you can either heat that up with some kind of heat gun or use a lighter like I'm doing. And that is the double connection soldered together. And now that we've added that extra 100mm onto the wire, we need to cut it back down to its original 920mm size. So I'll just snip the ends off the double wire so that they're exactly the same length. And then back on the measuring rule, just measure this out again to 920mm, and then just cut it down to length at the single wire side. So once you've got all your wires cut to length and you made up your double cables, next we need to move on to crimping the terminals. As I've already mentioned, I bought this cable crimp tool from Amazon. It cost around about £15, and after a bit of practice it does a really good job of crimping these terminals in place, but there is kind of a way that you have to do it, and if you don't do it that way you'll make an absolute mess of it. So to crimp the terminals onto the wire using these terminal crimps, we need to use the part of the jaws that reads 1 to 1.5mm, because that's the diameter of the conductor on this 16 gauge wire. You need to take one of the terminal pins. You notice that these pins have two sets of wings on them. At the back the wings are longer, or the tabs are longer than the ones further forward. Put the terminal pin inside the crimp tool where it says 1 to 1.5mm. You need to make sure you get those longer wings at the back, push right up to the stop on the jaws of the crimp tool. And once you have that in, you just start tightening up the crimp tool just until it starts crimping the terminal pin. You need to make sure that either ends of your wire have the sheathing stripped off, probably around 3 or 4mm, 5mm maximum. And then you need to feed that into the terminal pin. You need to give it a really good push, make sure it's all the way in. Then once it's in, just clamp down on the tool fully and then open it up. Then if you've done it right, you should have a perfectly crimped terminal pin on the end of the wire. So again, this is quite time consuming, especially when you're doing the 24-pin cable. Obviously the PCIe cables and the EPS power cables are a lot quicker because there's only 8 wires to do for each one. But what I'd suggest to do is strip back all the pieces of wire first, so then you can crimp all your terminals on, and then once they're all crimped on, you can move on to the sleeving. So now we have all the wires cut to length, the double wires have been made up, and we have the terminal pins crimped on either end of all the cables. So the next step is to apply the sleeving to each individual cable. We're sticking with this blue and black theme for the 24 pin cable. That means I'll need to have a row of 3 black, 6 blue, and then a row of 3 black on the 24 pin connector. So to do this, you need to take one of the pieces of wire that has a terminal crimped on either end. Get your blue sleeving, and before you do anything, you just want to melt the end of that so it just stops it fraying and holds it together. And then you need to take your wire and take your blue sleeving. Then to measure it out, you just want to start about halfway in between where the terminal pushes into the connector housing. So you just hold that together and then just pull it down the cable until you get to the same position on the other end. So halfway along that part where it pushes into the connector housing, and then you just need to use your snips, snip that off, and then again just melt that end just to stop it fraying for now. So there we have a bit of sleeving cut to length. So for the next part, you just need to push this cable with the pin on and start feeding it down the cable. It'll probably go down the cable pretty easily for so much of the length, and then you have to start kind of feeding it through by just gathering the sleeving together and then grabbing hold of the cable and letting go of the sleeving, just so that you can feed it all the way down until you get to the other end. Then once you have the other end of the cable poking out of the sleeving, you need to take some of the heat shrink wrap. Just cut about 15mm off. I'm going to cut 2 of these off, one for either end. Now there's 2 ways you can do this. You can either put the heat shrink over the cable and just heat shrink it in and just leave it on like that, or you can do another method, which I prefer to do, is where you hold the sleeve in about halfway down the part of the connector that pushes into the housing, and then just slip the heat shrink wrap over the top of that, and then you want to melt it in position or shrink it in position using your lighter, and then you want to just the very end heat it up until you see the heat shrink wrap start bubbling and melting. And then be careful with this bit because it is very hot. You might want to wear some gloves. And then just mould that into position, and then either using your snips or a Stanley knife, cut that heat shrink wrap off, and then you'll see there's a bit of the sleeving that is actually melted around the terminal pin, and that means now you'll be able to push that into the connector housing and you'll not see any of the heat shrink wrap. It just looks a little bit better doing it that way. So for the other end, just need to pull the sleeving tight down the cable. So just pull it tight right down to the other end. And then same again with the sleeving about halfway up the middle of the terminal where it goes into the connector housing. Just slip your heat shrink wrap back over, melt it down, then just heat up that end piece so that the sleeving is melted to the connector. And again, very careful, and just mould that into position. Take your Stanley knife again, just cut that off. So there you have one of the individual cables sleeved in this blue PET sleeving. That's ready to go into the connector housing once we've sleeved all this lot. So to sleeve your double wires, the process is very similar, but there is a slight difference. So you need one long length of sleeving and then two shorter ones. And then from the end of the cable that just has the single terminal, you need to thread on your longer piece of sleeving as you would do normally. And thread that right down to where the two cables meet the single one. Then, as you did with the single cable, put your piece of heat shrink wrap over the end and then melt it in place so it actually melts the PET sleeve into the connector. Then pull it down as far as you can. Slide another piece of heat shrink wrap all the way down and then just shrink that piece down. And then it holds the cable in position. And then thread one of the smaller pieces of sleeving over the short piece of wire. Again, use the heat shrink wrap. Melt that in position. Same again with the other short piece of wire. Push your short piece of sleeving over. Slip your heat shrink wrap on. Melt that in place. And then using a wider piece of heat shrink wrap, this is approximately 10 or 12 millimeters. Just cut a bit of this off, enough to cover both of the cables. Slide that over both the cables. Shrink that down. Shrink it down as much as possible. And then finally take a longer piece of the 5mm heat shrink, put that down the wire from the single terminal end and just try and slip that over the top of everything and then just shrink that in place. And there you go, that's the reason why you make these ends only 100mm long, because you'll be able to hide this slightly ugly bit of cable underneath your power supply shroud, or just hide it out of the way, and then make sure that the single nice looking end that will be on your 24 pin connector in view on the motherboard. Now we have all the individual cables sleeved in blue and black PET sleeving. We now need to revert back to the pinout template we made earlier, and we'll also need the 24 pin connector housing, and for our Seasonic power supply we also have an 18 pin and a 10 pin connector. These both go at the power supply side. Now we can start off with the 24 pin connector, and if you look closely at the 24 pin connector at the back, you can see it is actually numbered, and pin number 1 starts at this side on the bottom row. So we need to take one of our black sleeved cables and then push that into the slot for pin number 1. It'll just click into position. There's two little tabs on the connector terminal pins, and they just locate and lock into position. You'll hear them just snap into place. For the 24 pin side, there's not really a big emphasis on making sure each individual cable is in the correct position. Obviously, if you're doing two different colours, you need to make sure the coloured cables are in the correct positions. But one thing you do have to watch out for is your double wires. Because we're going to be using these cable combs, it'll be very difficult to push the cable comb over a double wire. So we need to look at where these double wires go in the 24 pin connector. So if I look back on this pin out, we can see that pin 10, that is a double wire. So what we need to do is take all of our cable combs and slide those down the first wire that we've got in. And those cable combs sort of line up with the terminal holes in the connector housing. So now we need to take one of our double cables or double wires and line that up with pin 10, which is this hole. Push that through all the cable combs, and then push that end of the wire into the corresponding hole for pin 10. So that's in place, and all the cable combs are over that wire. And then our next double pin is pin number 3. So take another one of the double wires, find pin number 3, so that's on the bottom row, and that's 1, 2, so that's number 3. Push that through like we did with the other one, and push that into pin number 3. And then there's just one more double cable, and that is pin number 2. So that is quite easy because it just goes right next to the last one we did. Same again, just push it through the cable comb, slot it into pin number 2. So that's all the double wires connected up at the 24 pin side. Now we just need to slide all the rest in the pattern, or the blue-black pattern that we're going for. So all the individual wires are connected up to the 24 pin side. Pin number 20 is missing. That's how it is on the original Seasonic cables. The next step is a little bit more technical, and this is where you really have to pay attention to the pinout diagram that we made earlier. So starting with the 18 pin connector. Again, this connector is numbered. The majority of these connectors are. But the way to work it out is if you're looking at the connector from the side where the wires are inserted, pin number 1 will be at the top left hand side. Pin 18 is at the bottom right side. So now we need to revert back to our diagram, and using our digital multimeter. Start from pin number 1 on the 24 pin connector. Now you can either use your digital multimeter or you could just follow that wire round to the other end. So pin number 1 is this one at the top left hand side. So if we just follow that wire round to the other end, that should be pin number 1. So I'll just double check that using the multimeter and set it to resistance. So if I just put that in, pin number 1. There you heard the bleep, so we know that is the correct wire. So pin number 1 on the 24 pin connector goes to pin number 18 on our 18 pin connector. So pin number 18, push that in there. And then now pin number 2 on the 24 pin. So if we just follow around pin number 2, pin number 2 is one of our double wires. So one of the double wires, which is pin number 2 on the 24 pin, goes to pin number 17 on the 18 pin connector. So we'll push that one, or one of those, into pin number 17. And then you need to just keep going over that same process until all the wires from the 24 pin are going to the corresponding 18 pin and 10 pin connections. That's all the cables made up. They're looking really good out here on the bench. I can't wait to get them installed in the system and see what they look like when they're installed in there. But before we do that, we need to just make sure 100% certain that we've got all the pinouts correct. So these new cables, they match the originals absolutely perfectly. To do that, the best thing to do is do an internet search for ATX pinout or something like that, and it'll tell you exactly which pin carries what voltage. A PC power supply outputs 3.3, 5 volts and 12 volts, and it also has ground pins as well. So we just need to make sure that these correspond to how they should be in the original cables. If you have one of these AlphaCool work surfaces, the cable pinouts are actually printed on the surface, so I'll be using this as a reference. The only tool you'll need to test these cables is a digital multimeter, and you will also have to jump the power supply, so we just have to bridge the switch pin to ground. And I've just used an old piece of wire. You could use a paper clip or something like that and just bridge the pins. Again, if you do an internet search, it tells you which pins to bridge, and that just jump starts your power supply as if you've pressed the power button on your system. So all we need to do is connect the negative terminal of the multimeter to a ground. So the casing of the power supply is grounded, so I'll just wedge that in there. So start from pin number 1 on the ATX cable, and that should be 3.3 volts. Pin number 2 is also 3.3 volts. Pin number 3 should be ground. Pin number 4 should be 5 volts. Pin 5 is ground. Pin number 6 should be 5 volts. Pin number 7, that's ground, that's correct. Pin number 8 is the power OK button, and that's 5 volts. Pin number 9 again is 5 volts, that's correct. Pin number 10, that's 12 volts, and that's correct as well. Pin 11 is 12 volts. And then pin number 12, that is 3.3 volts. So you can see how that's done, and it's the same process for the PCIe cables, EPS cables and the SATA cables. Just need to make sure that everything is absolutely perfectly 100% correct, because the last thing you want to do is plug in this 24 pin to your motherboard or the PCIe cable into your graphics card, and it could potentially have some voltages wrong and cause some damage. So yeah, just need to double check or even triple check that these cables are correct before you plug them into anything. And if you do realize that you have made a mistake and you detect it during this testing process, don't worry, not all is lost. There is a way to resolve it. You can actually remove the pins from these ATX connectors once you've fitted them, and this is where the staples come in handy. So all you need to do is just straighten out 2 staples or one side of 2 staples, and then right down the edge of the pin or the terminal, just slide the staple down. There's a little groove where it should go, so just slide a staple down one side of the pin and then slide another staple down the opposite side. Give it a good push to make sure it's all the way down, and what that does is it just bends the little tabs back on the terminal pins, and then it allows you to just pull them out of the connector housing, and then you can just switch around, figure out which pin you've got wrong and just switch it round and put it back into the correct place. It's as easy as that. There is actually a specific tool for removing these ATX pins, and it's not expensive, but I still use the staple method. I find that it's effective, and staples are something that you're more likely to have lying around the house. So it's really simple, and so don't worry if you have made a mistake. It can always be rectified by just switching the pins round. So now that we've got all the cables ready, I think it's time to install these in the system and see how they look. All the power cables are installed in the system. I've done a bit of work around the right hand side, just neatened them up and managed the cables around there. And I have to say myself, I'm really impressed with how they look. I'm really happy with how they've turned out. I think the blue in the middle of the cables will work really well with the other blue highlights that are going to be in the system and the blue lighting that will be in there. So yeah, it should really look smart when it's all finished, and I'm really happy with how they've turned out. One other area of the PC system that can often look a little bit untidy or a bit messy is the front panel cables. In this Fractal Define 7 XL, they're not too bad because they are all black cables and one of them's sleeved, but the rest have just got a PVC sheathing on. Sometimes you get multicolored cables and they can look really messy. I'm going to see if I can make them look a little bit better. If there's any other cables that I can sleeve, that's what I'm going to do. But it looks as though the USB 3.0 and the USB Type-C cable, they're going to be quite difficult because they've got moulded plugs on either end. So I think I'll probably leave those. Like I say, they're not too bad. They are PVC sheathing, they are black, so they will match in with the theme of the system. But we do have the opportunity with the audio header and the USB 2.0 header to remove the pins from these connectors and maybe slide some sleeving onto those just to make them look a little bit nicer. So let's see if we can do that. So before you start dismantling these header connections, you do need to make sure that you know which pins go where. So you can either do an internet search, maybe search for USB 2.0 motherboard header pin out or something like that. If you can't find a pin out, what I like to do is just grab my phone and just take a picture of it. So with these, you need to take a photo of both sides because the pins go in both sides. So now if I'm struggling for a pin out diagram, I can just refer back to those photos when I'm reassembling this connector. We'll start with this USB 2.0 header, and the way that you get the pins out of here is there's just some little plastic tabs. You just have to lift those back. They're quite small, so I'm using a Stanley knife blade to try and lift them back. So once that's out of the way, you just grab hold of the cable, give it a pull, and then the pins just slide out. So obviously you need to do that with all of them. So again, it's a time consuming job, but it'll probably be worth it if the cable looks better afterwards. And then once you have all the pins removed from the connector housing, just try and slip some of the heat shrink wrap over all the pins. This 5mm heat shrink wrap should just go over. And then just temporarily just heat that up and shrink wrap the end of those cables. The only reason we're doing this is to try and make it a bit easier to slip the sleeving over this bunch of pins. Again, just measure out the length of your sleeving. That should do. Let's cut that off there. And now we're going to have to try and make the end of this as wide as possible. Just try and slip that down. So we have managed to get that all the way down the cable, but it has left it looking quite frayed at either end. So the first thing we need to do is remove this temporary heat shrink wrap that we put over the pins. And then cut another piece of heat shrink wrap long enough to cover all the frayed area. Just try and melt that down a little bit. And just squash it against the cable, and if we can slide this over the top of all these pins, and try and slip it over that frayed sleeving. Slide it down as far as you can. That should be enough. And we'll just shrink that down. And then to cover up the bit of sleeving that's frayed at the other end, I'm just going to use a bit of wider heat shrink wrap. This should make it easier just to slide it all the way down the cable. So I just slide that right down to the other end, then just shrink it down. Until it's a nice snug fit around that wire, and that should prevent any more of that sleeving from fraying. So I do think that is an improvement on the original PVC cable that we could see. All we need to do really is put this header back on, so you need to either revert back to your photo that you took or check the internet for the pin out. So get those back in the same position, and then we'll do the same thing with this audio header. front panel's installed back into the system, and you've seen that I've managed the cables and tidied up in the right hand side again. Everything's connected up to the motherboard, and I'm really happy again with how those couple of sleeve cables look. They're not a huge difference, but I think it is just those small minor details make all the difference. So system is really coming together now, and I think all that's really left to do is connect up the two SATA hard drives and get on with building the loop. So that is the next job. Time to build a custom loop. we are done. Finally, the Seasonic Aura system is complete. And you know what? I think it looks absolutely brilliant. It's turned out exactly as I was hoping when we started this project. I really love that mixture of brushed aluminium and the chrome, and that blue and black theme really sets it off. I'm really chuffed to bits with how it's turned out. I've been running a quick stress test with AIDA64, stressing CPU and GPU. Everything seems to be working exactly as it should be. CPU temperature under load is around about 65 degrees, and the GPU under load running about 40 degrees on the AIDA64 stress test. So it's exactly what you expect from a custom loop like this with two radiators. So yeah, it's all running great. So just to recap, if you didn't catch the beginning of this project, inside the system we have a Gigabyte Z490 Vision D motherboard, an Intel Core i9 10850K CPU, 10 cores, 20 threads, a Gigabyte RTX 2080 Super Gaming OC Waterforce graphics card, and it still has the original Waterforce GPU block on there. For storage, there is a WD Blue SN550 500GB M.2 drive, two more WD Blue 1TB SATA SSDs. Memory is Corsair Vengeance RGB, and if you remember, we did a bit of a mod to the heat sinks on that, so they now have kind of a brushed aluminium effect to them. Cooling of the system is provided by AlphaCool, so up top there's a 360mm rad, 45mm thick, and another 360 rad at the front of the system. Tubing is the AlphaCool chrome brass tube. It's a little bit difficult to use compared to your usual hardline tubing such as PETG or acrylic. Because we had no means to bend the tubing, we're kind of stuck with the angles that you can create by the fitting, so it is tricky. It takes a lot longer than a normal hardline build, but I'm really impressed with how it's turned out. I love that chrome, and I would probably use that again in one of my own systems. And then powering the system is the Seasonic Prime TX1000 power supply. And then in terms of the mods, you can see we've swapped out this power supply shroud for a brushed aluminium with Seasonic logo, laser cut out of the front. We also added some blue acrylic to that and then some custom lighting. We also have the two Seasonic Prime laser etched SSD covers, and down the front of the system next to the motherboard we also have another laser cut Seasonic Aura panel. We also modded the cabling, so we have all custom sleeved blue and black power cables. As I said earlier, we did the mod to the memory heat sinks, so they're a nice brushed aluminium looking effect to them now. We also had a custom GPU backplate made with a Seasonic logo laser etched onto brushed aluminium, and I've also just added a couple more LED strips to the floor of the case, so it just gives it like blue underglow, and that kind of complements the other blue parts in the system. I'm really happy with how it's turned out. I think it looks absolutely superb. Let us know what you think of the Seasonic Aura custom build in the comment section. Is there anything else you would have done different? Is there anything you would have added to the system? Let me know. And if you have any questions on how we put the system together and about any of the mods, leave a comment in the section below and I'll do my best to answer your questions. If you've enjoyed watching this Seasonic custom build, please don't forget to subscribe to the Kit Guru channel, hit the like button and hit the bell button for notifications. And if you want to help support Kit Guru in other ways, you can head over to our store, pick up some Kit Guru merch, and you can connect with us through social media on Facebook, Twitter, Instagram, and through our Discord channel. And as always, you can head over to the kitguru.net website where you can catch up on all our latest in-depth technical reviews and catch up on all the latest tech news. Thank you for watching, guys. I'll see you in the next one.